to be talking about reliable end-to-end testing with API contracts using Cypress and Pactflow. So hopefully something new for everyone here, or yeah, it'd be great to hear your experiences on this as well. So a little bit about myself. My name is Lewis Prescott. I'm a test specialist at IBM at the moment, and I have a book coming out, Contract Testing in Action. So it's very exciting, and some of this talk is also in the book. So I go by Pac-Man. I'm very much into this niche of working in contract testing, so Pac-Man is my name, and you can find me on Twitter as well. But yeah, so the agenda for the talk. So what is an API contract? So we'll delve a bit into kind of the background and the context behind how we embed this into Cypress. And then we'll look at integration testing challenges. So why would you want to go about this solution? And then obviously I'll show you how it all works within Cypress and Pactflow, a tool we use within contract testing. So first of all, if you can jump onto this menti.com and enter the code, or just scan the QR code. There's a couple of questions in there. We just want to get an idea of how your environment looks right now, what you're working with, and there's a couple of questions in there, so make sure you answer both of them. I just want to get a feel of who I'm speaking to and what you're working with within the world of Cypress. So if you jump across to there. Great stuff. So yeah, loads of people saying they are working with fully integrated environments, and some using mocks. So this talk is going to benefit both of you. So I will talk about the challenges of integration testing. So hopefully that will appeal to those people. And then obviously we're going to be using mocks, but what type of mock is kind of the key to the talk. And then hopefully not many people know anything about contract testing, so that's great. I'm going to be giving you a little intro today, and then obviously you can happily go and buy my book. Shameless plug there if you want to know more. But yeah, ultimately we're in the world of API testing here. We're looking at contracts between your web or your mobile apps into your backend services, and how we can make your mocks much more reliable and more valid. So some really good stuff in here. Interactions is exactly what we'll be talking about. Verification of those contracts. So some really good content within this word cloud. Thank you so much for doing that. So without further ado, back to the talk. So yeah, as I said, a bit of background behind what we're talking about. So the introduction of microservices, lots of people moving to a much more distributed systems world, and so the article that this came from coined it the new unit testing. Not sure we go that far, but it's definitely working in that world where you've got distributed systems of microservices. Contract testing really helps you in that environment where you've got lots and lots of different services that you're interacting with. And traditionally, when we looked at API tests, we're looking at monoliths that gather all the data that it needs, construct that information, and send it back to the consumer. Whereas in microservices, we've broken those all down, right? Each domain has its own interfaces, its own endpoints, and so we can see within that there's lots of different services that we potentially communicate with. And so Martin Fowler describes it much better than I can, but ultimately an integration test verifies communication paths and interactions between components. So what we're talking about here is, as you mentioned in the survey, was you're doing those integration tests. So communicating between those components and making sure that we are identifying any issues between those two components. And the reason why I asked you that question up front is, what are the kind of pros and cons of each approach, right? So if we work in a mocked environment within our end-to-end tests or our Cypress tests, then that doesn't necessarily reflect what's in production, right? The mocks may have gone out of date and need to be updated, or we could be relying on a data set which is not necessarily reflective of how it's being consumed. It's something that someone has created, not necessarily true to life. Then on the integrated side of the coin, we've got potentially difficult to maintain tests, expensive to run, and potentially run later in the process than we would like. And those dependencies that you have may be tricky to coordinate, may be causing you some challenges, but they also have pros on both sides as well, right? Your integration is your true to life. Is giving you as close to what's in production as possible. And then your mocked environment is giving you that stability, giving you that reliability and that control of running your tests in isolation and making sure that they're stable within your pipeline. So both have pros and cons, but there's the potential to maybe bridge the gap, and that's what I'm going to demo later on. And so what is contract testing? So the way that I like to describe it is we are flipping integration testing upside down. And so what do I mean by that? Contract testing is a way that you can test your integration points at the boundaries. So we are having that definition that we talked about from Martin Fowler. We are saying we are giving an integration test between interactions between components, but we are doing that in a mocked fashion where we are passing a contract between the two components. So we're doing it in isolation, we're doing it at the boundary without having to have the two integrations running at the same time, without having to rely on those environments for us. So that's what I mean by we're flipping integration testing upside down to create a contract testing scenario. And so what are the challenges that we face in that integration testing environment? Often back-end and front-end are separate. We still have lots of integrations which are written in the same languages for back-end and front-end, but generally, in my experience, I've worked in back-end teams and front-end is built in a different language, a different framework, and the two teams kind of operate separately in terms of, obviously, their expertise lies in different areas. You may have full stack engineers that can do both, but ultimately you're developing things individually, and that scenario creates this: the back end holds the data, and then the front end is requesting that data, and so you're trying to meet in the middle. You're trying to communicate, okay, this is what I want to receive, and this is what we want to send you, and then you have the conversations to kind of meet in the middle. So what are your front end concerns and what are your back end concerns? And then you create that contract, and then you follow that through the process, whether they get developed in sync together, or whether the back end is available first and then the front end integrates with it, or vice versa. And that's where the mocked and integrated also comes in to when you're developing your tests. And so this can cause some integration issues. Potentially, as I mentioned, the mocks may have not got developed as per the contract was agreed, or the mocks have veered away from potentially what the latest is, and you create these integration issues. It's not a case of blame, or it's not a case of people doing the wrong thing. It's just human nature, right? And it comes down to communication a lot of the time. So let me tell you about the scenario which I experienced myself, and how potential contracts could have helped me in this situation. So we had version 1 and 2 of an API. So the customer data API was servicing to two different apps. Multiple services also integrated, but for this example, I will just concentrate on these two. And so the mobile app had version 2 of the API endpoint, because obviously that was the modern web app that everyone was using and could use the latest version. We had a legacy desktop application which had release cycles up to 6 months and was still using version 1 because it found it difficult to upgrade, obviously, with that 6-month release cycle. And the data ultimately that was being surfaced to the two was held in a core model, which was shared between the two versions. So any changes to that core model would then be seen in both versions of version 1 and version 2. So we wanted to make a change to this API because we were getting bad data in the database. So the database was receiving data which then, when we queried, was empty or wasn't containing the right information. It was in a bad format or whatever. And so the update to that core model was making sure that we had that field and it was required and it was in the right format. But that unfortunately broke version 1 of the API because the legacy application wasn't compliant with that. And so if we had a contract in place where we knew how the desktop app was using that API endpoint, then we could get an understanding of how we wouldn't introduce any breaking changes. And so this is where contract testing really comes in, because you can have those contracts between your consumers and your APIs and your providers of that data to determine what the breaking changes are going to be and obviously prevent them going forwards. So that's just a scenario to demonstrate why this is a good idea, basically. And so, as I was talking about earlier, Martin Fowler describes the contract test as at that boundary of that external service. So you're making sure that the two integration points can communicate effectively, and obviously verifying that they are compliant with each other, but you're doing that at a boundary. So it's like your component tests when you're using those mocks, but you're sharing those mocks around. You're sharing them between teams so that someone can verify, have you received the contract? Do you agree that we can go ahead with this change? And so this is a diagram, well, a GIF from Pactflow demonstrating that process. So the consumer makes a request and a mock is returned and says, this is the mock data that I would expect and in this correct format. And then the provider of that data, the API service, can then run that mocked data against their own service that's running locally, and they can determine, okay, we agree, we conform with what you expect, and how you requested the data is how we are open to receiving it. So we can verify that two systems will work together without having to run this in an environment. We just share that mocked agreement is shared between the two systems, and then you can add in that verification status. So why is this beneficial? just a few things for now, and we'll come on to more detail later on. But using Pact gives you that ability to run independently, giving you that fast feedback, and making sure that we're using a stable mechanism, and they're easy to maintain because they sit alongside the code. And ultimately, the end goal, right, is we want to have that confidence to release that it's a lifelike scenario, and the integration points will be reliable. So where do these contracts, these mocks, get stored? So they get stored in something using the Pact framework. So Pact is an open source tool which implements contract testing and provides you with those helpers and that framework to be able to deliver it. So we have the Pact broker, which stores all those contracts. So the consumer will publish their contract that they've generated from their code, from their tests. They will publish that to the Pact broker, and then the provider will then pull down that contract to their local running service, run the test against it, and publish the result back to the broker. So that's the mechanism for storing those mocks and making sure that those mocks are up to date, making sure that everyone agrees that this mock is a valid thing, and then keeping those in sync with the latest versions. So this is the process just written down. So as I mentioned, you could be developing the web feature or the app feature in sync with the API, but ultimately the consumer test needs to come first, right? The web tests, so that we have those contracts in place because they generate the contracts, and then once we've developed the API and that's available, then those tests can be pulled down and run as part of the tests for that service, and so you can verify that the two systems work together. And so a point to reiterate heavily about contract testing is ultimately it's just a communication tool, right? You could be doing this already within your teams. You could have Swagger documentation. You could have a Confluence page which has your API specifications within them, and everyone's agreed to those. Everyone's signed off on those, and you could be updating those frequently and making sure that everyone's in sync. Everyone's happy with changes going in. Obviously, you can have mechanisms in place to say we're not going to make any breaking changes. We're always going to be backwards compatible. All those good things can be built into your process, but ultimately it comes down to communication. Like in the scenario that I described with the bad data, ultimately we can't keep having bad data. And it was just a communication thing that needed to be done with that legacy application to say, we're going to make this breaking change. When can you facilitate it? And to reiterate those benefits before I show you how it all works, those benefits that we saw is we're testing earlier in the process. Before we have an integration environment, we can use these mocks, these contracts to verify the integrations. And we gather that confidence within our continuous integration, and we can potentially move to a continuous deployment scenario. And the ability for us to visualize what the consumer behavior is. How is it being used? What fields are mandatory? What fields are potentially not being used or cared about from our consumers? And then we're doing it in isolation. So we've got that reliability, we've got that stability within our tests, and we can test that end-to-end scenario in isolation. So the isolated end-to-end tests, now we're coming on to the real part of the talk. Without that context up front, hopefully you've all been following along. So once we've got our contract, right, and we can publish it to Pactflow. So Pactflow is the software as a service for the pack broker. So in this scenario, I'm using Pactflow because it has a nice interface and it has the stub URLs already available for me. So I can just hit an endpoint and say, give me the mocked response that I want. And then within our Cypress test, we just need to add in an intercept to mock out that API response for the application that we're testing. And then we can run our end-to-end test. So what does that look like? So this is the Pactflow stub. So I've just used Postman to send that API request and get a stub response. So this is the Pactflow application, and this is a pack that exists within that packed contract. And I've asked it for the stub, and I've asked it for the movies endpoint within that stub, and that returns me an example response. Within Cypress, we can use a task function to then get that stub. So we can call that endpoint within Cypress with our authorization headers and return us that response. And so when we call this task, then it will return us that result so that we can add that into our intercept. So let me just show you how that works. Again, I'm just going to make a couple of changes because I'm just going to share my whole screen. So, okay, so we've got our task here that's now being called within our Cypress test. So this get stub one is calling that Pactflow endpoint to return us that mock response. And then we don't have the local server running, so this is going to be intercepted and return us that response that comes from Pactflow. So once we've got that as part of our courses, so the test that we're doing today, we've got a learning platform and can return us a list of courses. So once we visit the URL, we wait for this intercept to happen, and then we should have that course available for us. So if we pull up Cypress, so as you can see, we've got this very simple app which just returns us a list of courses, the name and the author, and we have this stub set up. So it's stubbing that endpoint and returning us a list. Without that, we will just say an empty page. But as you can see, because we're stubbing it, it's available here. So that's what the React app looks like. This is the pack broker. So Pactflow's pack broker, which has that relationship of we've got a courses endpoint and the student wants to see those courses on the web page. So they're the consumer. So we've got that contract all set up within our pack broker. So that's what's returning that response to us. And that's it. So yeah, you can see behind the scenes, obviously, this is the, as I showed in the slides, this is the stub that's returning us that response. And because this is a contract, this is a verified contract from the providers who provide the data. So we can have confidence in our Cypress test now that this test is now effectively a end-to-end test at the boundary. So this is using that mocked response, but it's the provider on the other side, the API provider, has verified that that is a valid mock. So it's kind of like an end-to-end integration test but in that boundary scenario that Martin Fowler described. So that's it. That's what I wanted to share with you all. And so obviously, if you've got any questions, then please feel free to reach out to me on LinkedIn or whatever. But yeah, happily check out my book or anything, any of my content on pacman.co.uk. But thank you very much.
Thank you so much, Lewis. We have a number of questions from the audience, so I'm going to dive right into those. Starting off with this one from Sebastian. How could you define the difference between contract testing versus simply like JSON schema validation?
Yeah, absolutely. It's a really good question. So the schema validation happens up front, right? So you share that between your services. So the provider will make sure that they're conform to that schema, and then the front end will have that schema validation built in. So that's all well and good for that static element. So you know the data that's coming back and forth conforms to that. But the contract testing adds in that dynamic element. So if you're making changes to that schema validation, right, you will potentially have those multiple versions that we were talking about. So that can add in that complexity. And also there may be fields which get taken out, removed, all that kind of thing. So it's that dynamic nature that contract testing is really offering that added value.
Awesome, thank you. And while we're going through the Q&A, there was a question from the audience. If you wouldn't mind going back one slide and leaving your QR code on screen. Oh, back a couple slides. There we go.
This one, you mean?
Yeah, I believe so. All right, let's go ahead and go on to our next audience question. What can we gain from contract testing when using GraphQL?
Yeah, so it is compatible with GraphQL. Yeah, obviously the contract nature is different within GraphQL because you're just querying all the data itself. The co-author of the book actually wrote those chapters, so she would be much better to answer that question. But again, with the GraphQL scenario, it comes down to that dynamic nature of changing things and data migrating from that expected format, and then it's that all those consumers, right? How are people using it? Potentially in GraphQL, you may have a huge data set which you're not utilizing the right areas. So understanding how your consumers are using it can help you in the future.
Excellent, thank you. Going on to our next question, do you have any suggestions for getting started with legacy APIs that are poorly defined and not so much on the documentation side?
Yeah, absolutely. So Pactflow has a bidirectional feature which allows you to use those existing APIs and retrofit your contracts onto them. So it would just basically generate those tests and generate those contracts for you, and then you build it from in the reverse, if you like. And so, yeah, it really gives you a jump start to understanding where those integration issues are happening, and much easier to debug because you've got start getting those contracts in place. But yeah, it's called bidirectional contract testing, is something to look out for. Excellent.
And we're going to do one more question from the audience. I'm going to share that on screen here. And this is just kind of a clarification question. So does Pactflow act as middleware with Cypress for running?
Yeah, effectively, yeah. So we've got that task, right, which is calling out to Pactflow. Obviously, you can point to your local contracts um, if you turn them into JSON objects. But yeah, Pactflow is kind of that middleware that is returning that stub response for us.
Excellent. All right, that is all the questions we have time for. Thank you so much, Lewis.